Metal. Many industrial machines contain steel parts that have to withstand great stress. The metalworking method that produces the strongest steel parts is forging, heating the metal, then forming it to the required size and shape. Steel forgings are made from scrap iron, pieces of used iron recovered from demolished buildings and old cars, as well as bits of new iron left over from the manufacture of iron products. Forge workers maneuver a gigantic magnet to lift 5 tons of scrap at a time until they've filled a 25-ton scrap bucket. The bucket empties 2 such loads into a fiery furnace whose temperature peaks at 1650 degrees Celsius. This is called an electric arc furnace because the heat's created by a strong electric current running in an arc between 3 electrodes. There are about 20 main grades and 100 subgrades of steel. They're produced by adding specific metals or non-metallic chemical elements such as aluminum, nickel, chromium, vanadium, manganese, carbon, and molybdenum. They also add the mineral fluorite to help fuse the metals, some of which are in the form of blocks called ingots. Throughout the 3.5-hour meltdown, they test and adjust the chemical composition. They try to attain the lowest hydrogen, oxygen, nitrogen, and sulfur levels, the key to producing strong, high-quality steel. Then they pour the sizzling molten metal into a 45-ton ladle that's lined with heat-resistant brick. They add aluminum and lime to chemically counteract oxidization, rusting caused by air exposure. Now they cast an ingot, a block of steel that they'll shape into a forging. The molten metal flows out the bottom of the ladle into a mold below. This bottom pouring, as it's called, makes for a smoother casting because liquid flowing downward doesn't swill around as much as liquid poured sideways. This forge can cast ingots weighing up to 42 tons. After several hours, the ingot solidifies and they turn the mold upside down to extract it. Then, over 12 hours, they reheat the ingot to 1200 degrees Celsius. This makes it soft enough to hammer or press into shape. To make large forgings, they use a machine called a forging press. Mounted inside is a forming die or pair of dies, depending on the technique they're using. The press applies thousands of tons of pressure, crushing the ingot and forcing it against the die. The steel, meanwhile, is quickly oxidizing with all this air exposure. They use a high-pressure water gun to remove the scales of rust. An ingot often passes through a die several times, or through a series of dies arranged in sequence. Each pressing forms the metal bit by bit into the final shape. Metal is composed of microscopic crystals. Squeezing it in a press bends these crystals, destabilizing the metal structure. But reheating the metal creates new crystals to replace the deformed ones. This restabilizes the structure, and because the new crystals are smaller, makes the metal stronger than before. That's why finished forgings require heat treatment in what's called an annealing furnace. They heat for a day or two depending on the grade of steel. Then they soak in a water and chemical bath for about 5 hours. This strengthens the steel even more. Finally, workers mount the steel forgings on lathes and milling machines. They remove the rust scales that form during heat treatment, then precision machine the forgings into what the client ordered, usually industrial parts such as rotors, spindles, and shafts. Many factories prefer to buy forgings in the shape of blocks or bars,